Hello everyone. Today we shall be focusing solely on resistance, how it is related to our current, on what factors it depends on, and how current and potential difference take our resistance in a circuit or how they differ as per the resistance in our circuit. Okay, so topics we shall be taking today. Factors on which our resistance depends. There are basically 4 factors, of which 2 are of prime importance. Remember, in our previous class, we have already discussed resistance. It is the property of any material which opposes the flow of current through it. So basically, if we are speaking of material, then our material must have some dimensions. So our resistance depends on the length of our material. It also depends on the area of cross section. Of our material. Visualize it as a pipe. Okay, we are taking our current as water flowing through any pipe. If we increase the length of our pipe, what happens? In limited time, we'll get less amount of water at the other end, right? Similarly, for resistance, if we take a conductor which is a long wire, through that long wire, a current which flows through it will be of less amount. Why? Because as the length of the wire is increased, its resistance increased. And when the resistance increases, the opposition offered to the flow of current has increased. And hence our current is decreased. You might have observed when you charge your phone through a data cable. If the data cable is of very short length and you charge it using a laptop, it charges very easily, right? And if we take a data cable which is of a larger length and then we use it to charge our mobile battery, what happens? It takes more time than that shorter cable. Now, why does it happen? Because when the cable is short, resistance is less, current is more. So it gets charged up quite easily and very fast. When the length is more, resistance is more, current is less. What happens? Our battery gets charged a little late, right? Then coming to area of cross section. Okay, again taking the analogy of a water pipe. If we take a water pipe, you might have observed it while gardening. What happens? When we just pinch the mouth of our water pipe, what happens? We have decreased the area. When we decrease the area, our water flows out faster, right? Now, what happens? Let's take the case of area of cross section. Again, we are going to take the analogy of our water pipe, alright? Suppose we have a pipe which has got greater area of cross section. Through that pipe, obviously more amount of water will come out. And if we take a pipe which has got very little area of cross section, through that it is so obvious that amount of water coming out will be less, right? So our resistance is inversely proportional to the area of cross section. When the area is more, resistance is less, current will be more. When area is less, resistance will be more, so current will be less. Okay. If we just combine these 2 proportionalities, what we get? That R is proportional to L upon A. Once we remove this sign of proportionality, we'll have one constant, rho, which is known as resistivity. Now, how are we going to define this resistivity? Resistivity is nothing but it is the resistance of any material when when that material is specified in its dimensions. Now, how are we going to specify our material? By taking the length of the material as 1 meter and our area of cross section is 1 meter square. When the dimensions of the material have been specified, the resistance that we get is the specific resistance or our resistivity. Another name for our resistivity is specific resistance. A specific word relates to the dimensions that we have already specified to get the resistance of our material. Okay, third point is the material. Now, how does resistance differ as per our material? According to the amount of current that any material allows to pass through it. Our materials are broadly classified as conductors and insulators. Conductors, any metal plate or copper wire through which current can be easily flown. Now, our metals are our conductors. Since current is easily flown, that means resistance of conductors is very low. Speaking of insulators, all our switchboards, they are made up of mica sheets or polyplastics. Since they are made up of mica sheets or polyplastics, we do not feel any current through that, right? So, amount of current flown through our insulators is very less. Since current is very less, that means our resistance is high. This is how resistance depends on our materials. In all the cases hereinafter, we shall be considering our material as conductors, which we shall be using in our circuit. Okay? Alright. There is also one more factor on which our resistance depends. That factor is known as temperature. It is not in our board syllabus, but to be broadly speaking, whenever the temperature of our conductor increases, what happens? The molecules or atoms on the uppermost surface, they get kinetic energy. They start to vibrate at their position. What happens when they vibrate at their position? They offer more resistance to the easy flow of the electrons on that surface. That means, if we speak of temperature for our conductors, as our temperatures increase, so our resistance offered to the easy flow of electrons increase. These are the 4 factors, but now let us solve a few questions which depend on our first and second factor, that is length and area of cross section.